Welcome back to A's Data Science. I hope you all are doing well in your academics and life too. Today we are going to do the week 4 graded assignment for maths 2. Let's see the first question. The first question says that which of the following statements are correct. The first statement is if A and B are two square metrics, then rank of AB is equal to rank of BA. Okay. So it is given that A and B are two square matrix, but in square matrix there are many type of matrix possible such as diagonal matrix, scalar matrix, upper triangular matrix, lower triangular matrix, and many more. So with the only one information that it is a square matrix, we cannot say that both the matrices will have the same rank. For example, the rank of this particular matrix 1001 is 2, whereas the rank of 1122 is 1, as row 2 is scalar multiple of row 1. Despite the fact that both are square matrix, they have different rank. And we know that in matrix multiplication, order of multiplying the matrix is important, as generally AB is not equal to BA. And there are trick or rule also there to find the rank of a product of two matrix, which basically says that rank of AB is less than or equal to minimum of rank of A or rank of B. So from these two specific reasoning, we can clearly conclude that if A and B are the two square matrices, then it is not necessary that rank of AB is equal to rank of BA. So the first statement is wrong. Coming to the second statement, which states that if A and B are two cross 2 matrices, then rank of AB is going to be less than or equal to rank of B. Since A and B are two cross 2 matrix, so the possible rank for both the matrices can be either three of them, which is 0, 1 or 2. We just say that the rank of AB is always going to be less than or equal to minimum of rank of A or rank of B. Now, suppose a case where the rank of A is 0 and the rank of B is either of the three. In this case, the rank of A to B is always going to be minimum of 0, rank of B, which is always going to be result in 0. So in this case, the statements validate. And similarly, if we check this for all the other case, like when rank of A is 1 and the rank of B is either of the three, or rank of A is equal to 2 and the rank of B is equal to either of the three again, then in both case also we can conclude that this statement is actually validate. So statement 2 is valid. The statement 3 said that if A and B are the two square metrics of order 2, then rank of AB is always going to be less than or equal to rank of A. So this question or this statement is same as the previous statement. Since we already find that the previous statement is true, so this statement is also going to be true. Coming to the last statement, the last statement says that if A and B are two matrices of order n cross n and the rank of both matrices is also n, so the rank of AB is going to be n. So this statement is actually true, and if you want I can brief it also. Since the both matrices is of the full rank, means that they are independent, means that they are invertible. And there is a fact or a statement that multiplication of two invertible matrix will always go into produce an invertible matrix, means that the resulting matrix of the matrix multiplication of matrix A and B will also go into produce a matrix which is invertible, means that it is independent, means that it is the full rank. Hence, the rank of A to B is also going to be n. Statement 4 is also correct. Show the correct statement for this question. Number 1 is statement number 2, statement number 3, and statement number 4. Now, let us move to the second question. The second question states that match the vector spaces in column A with the bases in column B and dimension in column C. And one more thing that is given, that M is a 3 cross 3 real matrix. Let us see the first vector space. V is equal to x, y, z, 0, zx, y, 0, 0, and a condition is given that x plus 2 times y is equal to z. So one thing that we can point out from here is that the number of free variable here is only 2, which is x and y, so the dimension of this vector space is going to be 2. The reason behind equating the number of free variables with that dimension of this vector space is that this free variable will one by one span the whole basis, and we know that the number of vectors in basis is considered as its dimension or rank. So first let us try to make the matrix of bases by equating x is equal to 1. If we make x is equal to 1, then the matrix that we obtain will be 1 0 1 0 1 1 0 0 0. And similarly, the second matrix in this basis will be going to something look like this, and if we now match the correct option with the given options, then it will be like this. A goes for 2, goes for 3. Third option is correct. Now let us look at the second vector space. The condition given for the second vector space is that A is a symmetric matrix. Symmetric matrix are those type of matrix whose original form and transpose form are same. So if we look at the general form of a vector space of 3 cross 3 symmetric matrix, then it will be something look like this. And the basis will be something look like this, which we can basically obtain by equating each free variable one by one with value as 1. Its rank will be 6. So the fifth option is correct. Now let us look at the third vector space. The third vector space is the upper triangular matrix, so that general form of the upper triangular matrix will be something look like this one, where there will be 6 free variables. So the rank or the dimension of this vector space is going to be 6, and the basis for this vector space will be something look like this, where there will be 6 matrices. Now let us see the third question. Consider the vector space A, B, C, D such that A, B and C are real number, and a subset is given which is a linearly independent subset of V. Then we have to choose from the given matrices which matrices will form the basis for these vector space when it will unite with this given subset. If we see the description of this vector space, then we can find that only A and C are real number. Since there are only 3 distinct real numbers in this vector space, so the dimension of V or this vector space is going to be 3 only, as there is only 3 free variable. It means that the basis for this vector space is going to contain 3 matrices, and we are already provided with the 2 independent matrices. Now we have to find which of the following matrices from the given matrices will form basis for this vector space, or basically will be independent from those 2 matrices. So to solve this question, what we can do is we can represent the each matrices here as a 3-dimensional vector, as there is only 3 free variables. So if we do this, then we are already provided with the 2 vectors. Now from the given matrices, we will make the vector one by one and put it in the matrix where already 2 vector are there, and check whether they are independent or not. If they are, then they will be a part of basis, and if not, then they cannot form a basis. First, let us see how can we transform a matrix in a 3-dimensional vector. Suppose a 2 cross 2 matrix of ABCD, so the 3D vector form here will be ABC. For example, vector of first matrix in given subset will be 2, 1, 1. And vector of second given matrix in subset is 1, 0, 0. So, initially the matrix will be something like 2 columns are there and the third column will be blank for now. Now let us see the first option. The vector formed by this matrix will be 1, 0, 1. And if we put this vector as third column and check the dependency of the formed matrix, then we can find that its determinant is actually on 0, means that it is independent. Hence, this matrix will successfully form the basis with other 2 given matrix. So, first option is correct. And similarly, if we check for all the other matrices given, then we can find that all other matrices will be dependent with given 2 matrix. You can do it by yourself and confirm this, and if you find any problem, then you can pause and see the solution also. Let's move to the question number 4. Question number 4 says that find the rank of a matrix A, where is equal to Aij is of order 2021 cross 2021, where Aij is equal to minimum of I or j. So, it is given that matrix A is of order 2021 cross 2021. Where each element is the minimum number of its row or column number. The best way to solve this question is to observe the patterns from the lower order square matrices where the each element or entry is the minimum of row or column number. So, let us first see the pattern, or what will be the rank of a 2 cross 2 square matrix where the each element is the minimum of its row or column number. So, if we create a matrix here in this case, it would be look like the first element will be minimum of 1 or 1. So it will 1. Similarly, second element will be minimum of 1 or 2, so it will be again 1. The third element will be minimum of 2 or 1, so it will be 1. And similarly, the fourth element will be minimum of 2 or 2, which is again going to be 2. Now if we find the rank of this matrix, then the rank which we are going to get is 2, as there are 2 non-zero rows. Let us now see the rank of 3 cross 3 matrix. So the 3 cross 3 matrix where each entry is minimum of its row or column number will be look like this one. Later, if we reduce this matrix, then we can again see that there are 3 non-zero row. So, rank of this matrix is going to be 3. And similarly, If we see the rank of 4 cross 4 matrix where each entry is minimum of its row or column number is 4. So, we can clearly see the pattern that when we take a square matrix where each entry is minimum of its row or column number, the matrix is always going to be a full rank matrix, means its rank is always n. So, for the matrix of order 2021 cross 2021 where each entry is the minimum of its row or column number, the rank is going to be 2021. Hence, the answer of question number 4 is 2021. Let us now move toward the question number 5. Question number 5 says that, consider a subspace W is equal to x1, x2, x3, x4, x5 and there are two conditions given, that is 8 times x1 plus 10 times x5 is equal to 0 and 9 times x2 plus 6 times x4 is equal to 0. What is the dimension of W? Okay, so we know that the dimension of a vector space is basically the number of free variable, and here we can clearly see that there are 3 free variable as x1, x2 and x3. So, from this point we can clearly say that its dimension will be 3. Other or a bit long method to do this question is, first we can module the x5 in terms of x1 and x4 in terms of x2. And later, form the bases by equating each free variable one by one with the value 1 and also finding its dependence variable. Like if we see the first vector of this basis, then it is basically equating x1 with 1, so x1 become 1, x2 will be 0, x3 will be 0, x4 will be 0 and x5 will be minus 4 by 5. In similar manner we can do for all other free variables. After doing this we will observe that there are 3 vectors in this basis, hence its dimension will be 3. Moving to the question number 6, which basically asks to find the rank of given matrix which is of order 3 cross 4. So, if we do a bit of row reduction to this matrix, then we will see that there are 3 non-zero rows. Means that the rank of this matrix is going to be 3. If you face any problem in reducing this matrix, then you can pause this video and see my steps, and even still you can't figure out, then reach me in comment box. Let us see the question number 7, which basically says that there are two matrix A and matrix B. We have to find the value of rank of A minus rank of B. Let us find the rank of both matrix first. Let us first check their dependency by checking their determinants. As we know that if they have non-zero determinant, then it means that it is a full rank. So, if we check the determinant of matrix A by expanding it along the last row, then we can find that its determinant is non-zero. Means that it is a full rank, means that its rank will be 3. And similarly, if we check for matrix B by expanding it along last row, we can see that its determinant is non-zero, so it is also a full rank. Hence, its rank is also 3. Now the difference between their rank ID 3 minus 3, which is 0. Hence, answer of question. Let us now see the question number 8, which basically says that V is a subspace spanned by these two given vector in R3. Then from the given following vector, how many vector will be a part of basis of R3 with the given two vector in the independent vector subset? So basically in this question we have to find that from the given vector how many vector are spanned by the given two independent set of vectors. Or basically we have to check which vector are linear combination if these two given vectors. First let us make a general form of linear combination of these two vector by multiply A with vector 1 and multiplying B with vector 2 from the given independent. So, the correct answer for this question is 3. In this question, there is a one more way to solve this solve. We are given with 2 vector already and have to pick third vector. So picking after third vector, if we try to make a matrix where each vector will be a column, then we can see that it forms a square matrix. So we can use the determinant method to check whether they are dependent or not. If it is dependent, then it can't form bases, and if it is not, then it can form bases. Both the method will give you the same results. Coming back to the next question, which is basically question number 9, which ultimately asks that find the value of C for which this given vector will be in the spanning set of these two set of vectors in R3. Okay, so this question is also similar to the previous question that we just did. Here again we have to find a general linear combination of these two given independent set of vectors, and after that we have to equate that general form with this given vector, and then we have to find the value of C. So after doing all this process, the value of C that we are going to obtain is 5. Hence, the answer of this question is going to be 5. Moving forward to the question number 10. It says that consider a subspace in R3 where Z is equal to hash times X plus 2 times Y. And its basis is also given where there are 2 unknown variables. And we have to find the value of 1 by P into Q. So, there is a dependency on the variable Z. It means that variable Z is not a free variable, hence there are only 2 free variables in this vector space, as the rank or dimension is going to be 2, means that the number of vector in its basis will be 2. First, let us make the general form of this incomplete basis. The first vector is P0 and 1. So it means that P is X and Z is 1. And from the given condition, we can clearly see that Z for the first vector will be equal to 3 times X. And similarly, the second vector will be 0y and 2 times y. And now if we equate the first general form vector with the given vector having unknown variable, then we can see that 3 times x is equal to 1 from the third terms. So it means that x will be 1 by 3. Hence, value of p will be 1 by 3. And similarly, the value of q will be 1 by 2. Now if we find the value of 1 by p into q, then it will be 6. Hence the answer of question number 10 is going to be 6. Now let us see the question number 11, which basically says that V is a vector space of 4 cross 4 real matrix of a upper triangular matrix where the sum of diagonal entries are going to be 0, and we have to find the cardinality of bases. So the general form of a 4 cross 4 upper triangular matrix will be something going to look like this. One more condition for this vector space that is given is the sum of the diagonal entries should be 0, means that a plus b plus c plus d should be equal to 0. So from this we can make the dependency of d more clear, that d is going to be something look like minus m minus b minus c. So the number of free variables here is 9, which is basically a, b, c, e, f, g, h, I and j. And we know that these free variables are going to span the basis of this vector space. So the number of free variable is going to be equal as the cardinality of the bases or rank of the vector space. Hence the answer of question number 11 is 9. Now let us see the last question. The last question basically says that U is a vector space of upper triangular matrix of order 3. V is a backspace of lower triangular matrix of order 3. The dimension of vector spaces U, V and U intersection V is represent as A, B and C. We have to find the value of a plus b plus c. Okay, first let us understand that what type of vector will be there in intersection of u and v. In intersection, the common element from both spaces are there. So, the common matrix from both space is a diagonal matrix of order 3. So, the dimension of u, or basically the number of free variable in vector space u, is 6. For vector space v is 6. And for intersection matrix it is 3. Hence, their sum is 15. So, the answer of question number 12 is 15. Okay, so that is it for week 4 graded assignment of week 4 in maths 2. I hope you all learned something from this. If you do, then don't forget to show us